Hello everyone, so I'll be attempting this 2023 Mathematical Methods Exam 2. So let's start. Alright, so the amplitude A and the period P of the function of this are going to be what? Well, amplitude is going to be just half. Can't be negative half because, well, amplitude cannot be negative. And period is just going to be 2 pi over n, which is going to be 3. So answer is going to be E over here. Okay. Now for the parabola with equation y equals to ax squared plus this, okay, where a, b, c belong to all real number, the equation of axis of symmetry is, so the axis of symmetry is just basically asking for x coordinate of the turning point. So let me just define this function real quick. So define equals to a times x squared plus 2 times b times x plus c. Alright, and menu for 1, differentiating it now, f of x. So solve that equals to 0 comma x. So our answer x equals to minus b on a, so a. Okay, and two functions p and q are continuous over their domains, this and this respectively. The domain of the sum of p and q is, so whenever you have a question like this, it's just going to be the intersection of the domain of P with intersection of domain of Q. So if I were to draw a number line, so 2 to minus 2 to 3 is this, and minus 1 to 5 is this. So intersecting is going to be between these two, so answer is going to be negative 1 to 3 exclusive. So it's going to look like it's E. Consider the system of simultaneous linear equation below. The values of k for which system of equation has infinite solution are okay. So we can just make y the subject for both lines, and infinite solution just means that two lines are exactly the same. So y-intercept and gradient are exactly the same. So by using that, now we can figure it out. So let's start off by making y the subject for both of the equations. So now we can say that minus k on 5 equals to minus 4 on k plus 1. And the second equation would be k plus 5 on 5 equals to 0. So now the common value of k between these two equations will be our answer. Now, just by looking at this, I think k equals to minus 5 will be our answer. But just to check, we'll also solve this in our calculator. So solve. Okay, so as you can see, our second answer gave us k equals to minus 5 or k equals to 4. So meaning our answer is just going to be k equals to minus 5. Okay, which one of the following function has a horizontal tangent at 0 and 0? So, horizontal tangent at 0 and 0, meaning that our graph would look something like this, and our tangent would be here, where this is going to be origin. So what I'm going to do, I'm just going to use tangent line function and see which one of the following will give us the right answer. So let's start off by option C, menu for 9. So answer is going to be D. Alright, moving on. Supposing that integral of this is going to be c, integral of this is going to be d, and this is, so we have to find the value of this. Okay, let me just draw the graph first. I like to draw visuals for these sort of questions. Say that this is our graph, and this is 3, and let's say this is our 10. So between this entire area is going to be c. Okay, and from 7 to 10, so 7 to 10, this area is going to be D, and we have to find what this area is. So this area can also be written as negative 3 to 7 f of x dx. Right. So we are basically just finding this area over here. So what I'm going to do, I'm going to call this area as x plus d is equals to c, because the whole thing is just c. So x is equals to c minus d, right? So minus c minus d. Of course, now we know the area, but we have to multiply it by a negative sign. So d minus c is going to be our final answer. So it's going to be D. Okay, moving on to question number 7. So the domain of derivative of f of g of x is, okay, so we know that domain of f of g of x is going to be equals to domain of g, which is going to be negative negative infinity to 1. Okay, now since the domain of f of g of x itself is going to be negative infinity to 1, the domain of the derivative will also be the same. However, unless unless the derivative has a special kind of graph where this is not a subset. So what I'm going to do, I'm just going to quickly find a derivative as well. So I'm going to define f of x equals to log of x, and define g of x is equals to square root of 1 minus x, and we have to find f of g of x. Okay, we differentiate that, so menu for 1, f of g of x. Okay, so the domain of this graph is going to be all real numbers except 1. But our original function, so f of g of x itself doesn't have the component of 1 to infinity. It is limited to negative infinity to 1. So our answer is just going to be C. So now moving on to question number 8. A box contains n green balls and m red balls. A ball is selected at random and color is noted. The ball is then replaced in the box. Okay, so the total number of ball is going to be n plus m. And we are finding, okay, in 8 such selection, what is the probability that green ball is selected at least once? So I'm going to say x equals to number of green ball selected. Okay, and we are basically finding probability that x is greater than or equals to 1, which is the same as 1 minus probability that x is equals to 0. Okay, so probability of selecting a green ball actually, so I'm just going to call it x because x is the number of green balls selected. I'm going to call it n over n plus m because that's the probability. And keep in mind that 1 minus n on n plus m is just going to be equals to m on n plus m because it's either green or it's going to be red. So this and this are the same thing, so just keep that in mind. So probability of x equals to 0. Now we can just use the binomial distribution formula, which would be 8, 0 times probability of success, which is n over n plus m to the power of 0 times 1 minus n on n plus m. Now as discussed earlier, this is just going to be simply m on n plus m to the power of 8, meaning that probability that x equals to 0 is going to be m on n plus m to the power of 8. Now of course we have to subtract it from 1, so n plus m to the power of 8. So this has to be our answer, so our answer is going to look like C. Okay, moving on. A function is given by this over here, okay, and you have to find the value of a such that f is continuous and smooth at x equals to 2 pi. So that means that they have to share the same x and y coordinate at x equals to 2 pi, and the second criteria is that the gradient of these two graphs must be the same. So I'm going to define these two graphs individually first. So define f of x equals to tangent of x on 2, and oh, I forgot to write e. Define g of x equals to sine of a times x. Okay, now what I'm going to do, I'm just going to find the derivative as well. So menu for 1 x, and then menu for 1 again, g of x. Alright, and what I'm going to now do is again define these two. So define df of x equals to that, and define dg of x equals to that. So now I can just use system of linear equation to do this. So menu 3 1, and we can say that. Okay, so now we know for it to be continuous and smooth. So for it to be continuous, the n coordinate have to be the same. So f of 2 pi equals to g of 2 pi, right? And df of 2 pi, because they have to be smooth, the gradient is also meant to be the same, equals to dg of 2 pi, comma a. Now we have to specify the domain of a as well, or else it will give us a general solution which we do not want. Now the option given to us are between -2 and 2, so I'm going to just say that A is going to be between -2 and 2, like so. Press enter, and that's our answer. So it's going to be C. And now let's move on to question number 10. A continuous random variable x has the following probability density function. The value of k is such that probability of x is less than k equals to that. So we do find the value of k such that this condition is met. So what we can do is integrate one by one. So menu for 3, 1 to 6 of x minus 1 over 20 dx. Enter. Okay, so this is already bigger than 0.35. So our answer is going to be between 1 and 6. So what I'm going to do is I'm going to replace 6 with k and solve that for equals to 0.35 comma k, and they want an exact answer, so I'm just going to press enter, not control enter. And k cannot be negative because, well, it's just outside the domain, and probability cannot be negative, so our answer is going to be square root of 14 plus 1. So it looks like our answer is going to be B. Okay, moving on to question number 11. Two functions f and g are continuous and differentiable for all x belongs to R. It is given that f of -2 is -7 and g of -2 is going to be 8, and derivative of f at -2 is going to be 3, and derivative of g at -2 is going to be 2. The gradient of the graph this at point where x equals to -2 is... Okay, so this one looks like a tough one. How would we do this? Okay, I don't know if this is the correct way of doing it, but how I would attempt this question is I'll just say that both of these functions are linear line because we are given the gradient. So we can say that f of x is equals to 3x because our gradient is going to be the same no matter what we have as our coordinate. I don't know if this is going to be right, but I'm just going to do it that way. Plus c. So we can just say that -7 equals to -6 plus c, implying that c is going to be -1. So our f of x is going to be 3x minus 1, and g of x is going to be 2x plus something. So we know that 8 equals to -4 plus c, so c is going to be 12, meaning our g of x is going to be 12 again. Okay. So now we can just define these two in CAS and find the derivative at x equals to -2. And of course you have to do, f of f times g. So define f of x equals to 3 times x minus 1. Define g of x equals to 2 times x plus 12. And now we can just differentiate. So menu for 1, x f of x times g of x. We get that, and now if I were to substitute in x equals to -2, that will give us 10. So I think the answer is going to be E, but I'm not quite sure about this one. If I'm making a mistake, just let me know down in the comments. Alright, moving on. The probability mass function for the discrete random variable is shown below. The maximum possible value for the mean of x is... Okay, so our mean is going to be defined by -k squared plus k plus 2 times -k squared minus 4k plus 1. Okay, so I'm just going to add all of this in CAS because I don't trust myself doing all the algebra. I can make silly mistakes and I do not want that. So that plus 2 times -k squared minus 4 times k plus 1, and enter. So this is what we get as our mean function. So that is going to be -3k squared minus 7k plus 2. And now let's find the maximum of this. So menu for 1, and okay, and solve that for equals to 0 comma k. So k equals to -7 on 6. Now this answer wouldn't quite make sense because k represents probability and probability cannot be negative. So, Hold on, let me just see if I can graph this function. So let me say k equals to x, and control C, control I2, control V. Oh, did not copy. Control C, control I2, control V. There we go. Ah, okay, I see. So as you can see, our maximum value of k is, lying. So our maximum point is going to be when k is negative. So we can't use that. Instead, we have to use k equals to what? K equals to 0, because probability can be 0. So maximum value of k here in this case would be k equals to 0. So if I were to say that e of x, given that k equals to 0, that would just give us 2. So I think the maximum mean will be 2. So answer is going to be E. Okay, so let us move on to question number 13. Okay, if my iPad cooperates. Cool. So this is a pseudocode question. This is pain, but it's alright. No pain, no gain. Sorry. Okay, so this looks like just a Newton method. Okay, yeah, it does say here Newton method. Good. And f of x is a function of x. This is derivative. X0 is an initial estimate. And from 1 to 3, so 3 iterations, we have to use this code 3 times and get the final output. Okay, no problem. So we can just use cast for this again. So we can define f of x equals to x cubed plus 3 times x minus 3. Enter, and now I'm going to differentiate that as well. Menu for 1, f of x, and define that as df of x equals to. Okay, so now we have all the things that we need. So our Newton's formula is going to be x minus f of x over df of x. Okay, and now we can just simply substitute in. So our initial value was given to be 1, so x equals to 1. Okay, we get 5 on 6. So now we have to substitute. That's one iteration done. So now we have to substitute 5 on 6. That's the second iteration, and this is the last one. And if I press Control Enter, okay, so 0.81773. So that looks like our answer is going to be C for this case. Fantastic so far. We're getting all the answers in the options, so that is a very good sign. Alright, question 14. A polynomial has the equation of this. The number of tangent to this curve that passes through the positive x-intercept is. Right, so I think I need to graph this real quick first. So what I'm going to do is just define. So define f of x equals to x times 3 times x minus 1 times x plus 3 times x plus 1. Okay, and now let's graph this. Control I2, f of x. Okay, menu for zoom out a bit. Okay. Okay, so our first tangent obviously is going to be through the x-intercept. So that's that. Now the second could be from here, so tangent to this point as well as passing to the positive x-intercept. So that this is our second intercept, second tangent I mean. So far 2 tangents. Can we have any more? Ah, yeah, so we can have one tangent over here. So one tangent over here through the x-intercept, positive x-intercept. And I don't think there's anything else. So nope, there's nothing here. I think the answer for this is going to be 3. So, yeah. Okay. I'm gonna go with 3. Anyway. Question 15. So let x be the random variable, normal random variable with mean of 100, standard deviation of 20. Y be the random normal variable, 80, mean of 80, standard deviation of 10. And we have to find out which of the diagram best represents these two graphs. Okay. So a dotted line is going to be x and bold line is going to be y. So let me just draw a rough one. So mean of 100. So let's say our mean of 100 is here somewhere. So it is going to look, oh sorry, this is going to look like that, something like this. This is going to be our Actually, I should draw a dotted line. So this is going to be our x, like so. And if I were to say, and okay, standard deviation is bigger. Okay, now let's say y. So mean of 80 is going to be, let's say this is 80 over here. Now this graph is going to be like a bit more steep because the standard deviation is less, so it is going to look something like this. So our best match over here looks like option A, so I'm gonna go with option number A. Yep, it's option A. I couldn't see option E, but yeah. Okay, so f of x is this. Given that the product is going to be this, the rule of function g is going to be what? Okay, so g of x is going to be e of x minus 1 whole squared divided by divided by f of x, which is going to be e to the power of x minus 1. I'm just going to use cas for this as well, just to be very safe. So that is going to be e to the power of x minus 1 squared and e to the power, not x, so e to the power of x minus 1. Okay, so that gave us e to the power of x squared minus 3x plus 2. And if I were to okay, so there's some factorized answer. Okay, so if I were to factorize the quadratic, we'll get x minus 2 and x minus 1. So that matches option B. So I'm going to go with B. The cylinder of height h and radius r is formed from a thin rectangular sheet of metal, length x and width y, cutting along the dashed line shown below. The volume of cylinder in terms of x and y is given by. Okay, so we know that x is going to be equals to 4r plus h. Okay, so that makes it a bit more easier. How would you calculate y? Okay, I see. Y equals to circumference, because if I were to fold, this paper, y would technically just exactly match the circumference of this circle over here. So y equals to 2 pi r, meaning that r equals to y on 2 pi. So we can just use that now. So volume of cylinder is going to be pi r squared h. Okay, so the h we can get from this equation over here. So x equals to 4y on 2 pi plus h. So that is just going to be 2y on pi plus h. So therefore h is equals to x minus 2y on pi. Okay, volume equals to pi times r squared, so y on 2 pi whole squared times h, so x minus 2y on pi. And let me try simplifying this on cas to see if any options match. So pi times y on 2 pi squared times x minus 2 times y on pi. Okay, so we get pi x minus 2y y squared on 4 pi squared. Okay, so it looks like option B, because they have just expanded this, so this will just become pi x y squared minus 2y cubed on 4 pi squared. Okay, yeah, option B it is. Alright, moving on. Consider the function this. Okay, so they are given us a domain and sine graph where a is a positive integer. The number of local minima in the graph of y equals to f of x is always equals to. Okay, so this is like, there has to be some sort of pattern to this. So what I'm gonna do, maybe I'll just have a slider. So sine of a times x given in the domain of negative a times pi and less than or equals to x. Can I do this? Less than or equals to a times pi. Okay, so when a equals to 1, we have one minimum over here. If I were to increase this, a equals to 2, now we have 1, 2, 3, 4. Okay, so when a equals to 1 we had 1, when a equals to 2 we had 4. Oh, okay, a equals to 3 we have a lot. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like a squared. So our pattern looks like, yeah, I think it's going to be a squared. So I think the answer is going to be E over here. Okay, moving on. Question 19. So find all the values of k such that equation x squared plus 4k plus 3x plus this equals to 0 has two real solutions. For x, one positive and one negative. Right. Okay, so let's say that this is our parabola. Okay, this is our parabola. So we want value of k such that our parabola stays between these two range. Okay, so if I want my parabola to exactly just have an intercept as origin and some other point, that would mean that this part over here has to just become 0. Right, so we can say 4k squared equals to 9 on 4, meaning that k has to be equals to plus or minus 3 on 4. And okay, so it has to do with something 3 on 4. Now, I'm just going to look at the option. It can't be option A because the thing is, it has to be between negative 3 on 4 and 3 on 4. Because if I were to just, have, greater than negative 3 on 4, it will have, like, it'll maybe have chances of having all positive or all negative x solutions. So it can't be that. It can't be B either. It can't be C either. I think it's going to be D. It cannot be E either because, again, we are excluding everything other than the actual answer, so it can't be E. So I think the answer is going to be D over here. Okay. Moving on, so let f of x equals to this and g of x equals to this for x is that. The largest interval for which f of fog and goff is defined is what? Okay. So f of g of x is going to be log base e sine of x plus 1 on square root of 2. And g of f of x is going to equals to sine of log base e of x plus 1 on square root of 2. Interesting. Okay, so for this over here, we can say that sine of x has to be, sine of x plus this has to be greater than 0. So that would mean sine of x has to be greater than negative 1 on root 2. So if I were to, maybe I should draw this on CAS. So what I'm going to do is, I'm going to draw this. So Control I2, sine of x, sine of x, and negative 1 on square root of 2. So it has to be greater than that. Right. Okay. What will be our solutions? So maybe I should solve. So solve sine of x equals to 1 on, negative 1 on square root of 2, comma, x. And now we have to define a domain too. So let's have a domain. Maybe I'll say, let me see the graph again. Maybe I'll say from negative pi to pi. Okay, negative pi to pi. So x equals to minus 3 on 4, x equals to minus pi on 4. What if I say 2 pi? Because none of the options here have like negative, like there are a couple, but I don't think they're going to be it, but I'm just going to try. Okay, so 5 pi on 4, we have a couple of 5 pi on 4 in the options, so I'm going to leave that for now. Okay, so I'm going to leave this for now, with keeping in mind all of these x values. Now coming back, we can see that we have this function over here we can also work with. And now if I were to look carefully, they say that the range of this sine function has to be between, sorry, not the range, but the domain has to be between negative infinity to 5, meaning that meaning that log base e of x plus 1 on 2 has to be less than 5, right? Now that is because x has to be less than 5, so since our x value over here is going to be this whole thing, I just said this is less than 5. So what happens if I solve for that? So log x plus 1 on square root of 2 has to be less than 5 comma x. Will it give me a solution? Okay, so right, okay, so we have to so this gave us a domain of negative, oh sorry, not a highlighter, negative 1 on root 2 less than x less than 2e to the power of 5 minus root 2 on 2. So this is a domain that we got from solving this over here. Now we need to do something about this. So what would be a good domain for this? Now that would be, okay, if I were to go back to the solution, then maybe our one domain could be negative pi on 4 to 5 pi on 4, because these are the most repeated numbers throughout the option. So I'm just going to use that for now. And next thing we have to do is to find the intersection of this domain. So what I'm going to do is maybe I'm going to find out which one of the following is smaller. Is it going to be negative pi on 4 or negative 1 on root 2? Okay, so it seems like negative 1 on root 2 is going to be bigger. I see. Okay, so yeah, okay, so that's going to make it a lot more easier now, because oh, and also which one is bigger? Is it going to be 5 pi on 4? Or, okay, so 5 pi on 4 is that, or is it going to be this? Okay, it's going to be that. So negative pi on 4, which is going to be negative 0.78. So negative pi on 4 to 5 pi on 4, which is going to be 3.926. I'm just going to write this as decimals to negative 0.785. And this is going to be our one timeline. The other timeline is going to be negative, okay, this is going to be quite a big number, so negative 0.707 and 147, whatever it was. Okay, so the intersection of these two domains is going to be between these two. So our answer has to be negative 1 on root 2 and 5 pi on 4 exclusive. So it looks like our answer is going to be A. Okay, so that's it for all the multiple choice questions. And if there are any mistake, of course, you can just let me know down in the comments. I will be on to doing the extended response soon. Thank you for watching.